Okay, coming at you with another video on composition of functions, doing a little extra practice since I know the last video I did was on the short side, and maybe a few extra practice problems would be of interest. So let's talk about, it's basically a repeat of what we did before. We had a worksheet with 6 problems like this. I'm going to do this again, but we're going to talk through it just for a little extra reinforcement. So let's remind ourselves, first of all, of what this means right here. This is saying that we've got g of 3, and then whatever that is, we are then going to take that number and do f of it. So it's going to be f of some number, and we have to figure out what that is by doing g of 3. All right, well, let's get on that then. What is g of 3? G of 3 is 2 times parentheses minus 4. 2x minus 4, replace the x with parentheses, and then we're going to fill these parentheses with what the parentheses over here are filled with, which is a 3. So that means we've got 6 minus 4, which is 2. Then we're going to do f of the result. We now know that this number right here is 2. So f of 2 is 7 times we don't know plus 4. The we don't know happens to be a 2. We actually do know. And so we have 7 times 2 is 14 plus 4 is 18. And so it's just a two-step process. We're going to feed the first number into the inner letter and then the result into the outer letter. So if we were to look at number 3 here, f of 3. Okay, so same exact idea. We're going to say f of 3 is on the inside, and f of 3 is 7 times something plus 4, and the something happens to be a 3. 7 times 3 is 21 plus 4 is 25. And then that's for the inner part. And now we're going to focus on this outer f. I'm going to say f of 3. Well, we know that f of 3 is 25, so it's f of 25. And so this is 7 times stuff plus 4, where the stuff is 25. All right, 7 quarters is $1.75. So we have 175 plus 4, which is 179. Okay. Number 2. Yeah, I did 3 before 2. Fight me. So g of f of 4. I'm going to write this one in a slightly different format, just to point out that this is another way we can do this. So we're going to say that g of f of 4. So this is g of, and now we're going to do f of 4 inside. So I'm going to say 7 times stuff plus 4. And the stuff happens to, or wait, yeah, f, 7x plus 4, 7 stuff plus 4, and the stuff is also a 4. So it's g of, we're going to figure this out, 28 plus 4 is 32. Okay, so g of 32 is 2 times stuff minus 4. 32, 64 minus 4 is 60. I'll do one more and then I want to pause and talk about something that occurs to me we might want to address here. So g of 5. So g of 5, g of 5. We'll use colors here just to help emphasize. Is equal to g of. All right, let's do g of 5. Well, g of 5 is 2 stuff minus 4, and the stuff happens to be a 5. So 2 times 5 minus 10. 2 times 5 is 10, minus 4 is 6. So we need to do g of 6. All right, so g of 6, 2 times something minus 4, and the something is a 6. 2 times 6 is 12, minus 4 is 8. All right, now I do want to talk about one thing very briefly here, and that is the concept of using different letters. So regarding, slightly large font for what I wanted. So regarding letters in algebra, this is not a hard and fast rule, but in general, usually the later part of the alphabet, so X, Y, Z, U, T, these are letters that we use as variables, strict variables. Usually the very beginning of the alphabet is for constants. So A, B, C, sometimes we'll go as far as D. So these are numbers that don't change, but they are numbers. And then typically the early-ish letters, meaning F, G, H, are used for functions. So these aren't numbers at all. They are number changing processes. Right? Remember in the other video, I phrased it as a number change, as like a machine on a factory floor. The F is the machine, it's not a number. So one of the things that can often get people confused with these problems is that they go, letters, all kinds of letters, I don't understand what's going on. Why doesn't G parentheses 5 mean G times 5? And it doesn't mean G times 5, it means apply 5 to a process that we called G. So one of the things that we have to remember about algebra is that letters used in algebra are not there to function as letters. They are just a symbol. In theory, we could have used any symbol. Letters just happen to be the symbols we're most used to, other than the numbers, which are obviously not something we want to use in place of other numbers. But if we wanted to, we could have used any other symbol. We could have said, instead of f of x, we could have said f of smiley face. Oh, that's a terrible smiley face. Come on, give me a nice looking smile. I guess that'll do. We could have said g of popsicle stick, right? You can make whatever symbol you want. You could use Greek letters, you could use hieroglyphics, you could use phallic imagery if you really wanted to. It really doesn't matter. But the point is that these symbols, we just kind of adhere to these conventions over here on the right. So do not get dissuaded when you start seeing F and G and X and C and Z and E and I. I guess E and I are special cases that we should point out that E and I, E is like a number of about 2.7. I is the square root of -1. Those are specialized numbers. And it's about 2.7. It's a number like pi. It goes on and on forever. If you haven't learned about E yet, don't worry about that one. But we're not going to use the letter E for anything other than a very specific number. All right, so that out of the way, let's come back to our GOG of X here and remember that this literally is the same thing as G of X. You'll notice when I've been writing this, I've either been using brackets for the outer one or I've been using a big set of parentheses and a little set of parentheses. You're not required to do that. If you were writing this in a spreadsheet of some kind, either Google Docs or Excel or whatever, it wouldn't do that. But I'm writing it this way because I think it makes it a little easier to track. Another place where you wouldn't see that is if you were writing parentheses on the calculator. But I'm going to write it this way just to emphasize G of X. Okay, so there's two things that are different about this question. The first is that they use the little circle notation to represent composition. The other thing that they did different is they're not giving us a number. They're saying, let's just do it in formula form. And that's a little awkward, but I'm going to do it the way that I did numbers 2 and 4, which is I'm going to say g of, what is g of x? This g of x is 4x plus 2. Or if you prefer, when you feed a x into the parentheses, what do you get? Well, you get 4x plus 2. So obviously that's a little silly to write, but yes, that would be a way to think of it if you really wanted to. So 4x plus 2, and now we're going to do g of that. So this outer g now, we have to say, all right, so it's 4 stuff plus 2, but the stuff happens to be 4x plus 2. All right, now this case, we got to use our plain old arithmetic rules. So we're going to distribute a 4. We're going to get 16x plus 8 plus another 2. And then we'll combine like terms and we'll get 16x plus 10. Hopefully you're writing on the paper. Will be a little neater than my attempting to write things with a mouse. Presentation does count for something, but I'm just trying to get it all down on paper so you can see it here. All right, f of x, same idea. So we're going to treat this as f of x. Okay, well, what is the internal f of x? It's just plain old f of x, so it's 8x. Keep in mind, of course, that these two questions are using a different set of f and g, right? We were using a specific f and g for 1 to 4. We're using a different f and g for 5 and 6. I hope I didn't confuse you on number 5 with that. All right, so with this particular f of x, now the outer f of x, we got to go, all right, well, it's 8 stuff, but the stuff is 8x. So that means it is equal to 64x. So there is a run through of everything that would show up on this specific worksheet. Now, I feel like maybe it's worth going into this a little more detail. So let's make up a few questions of our own here. Let's let f of x equal 2x plus 3. Let's let g of x equal 4x minus 5. And let's let h of x equal x squared minus x. All right, so I'm going to start using this specific set of f, g, and h to make a few problems. So number 1, let's ask ourselves, what is h of 4? No composition. I just want to address this specific h because we've got multiple x's in here. And that's not a problem. This is just a quadratic. It's going to be something squared minus something. And the something is a 4. So this is 16 minus 4, which is 12. All right, now that we've done that, let's ask ourselves, what is f of g of 6? Okay, so inside function is the g. So we're going to apply the 6, or the 6 is going to be fed into a g, and then the result of that is going to be fed into an f. So let's feed 6 into g. 4 times something minus 5, which puts a 6 here. And I realized that I didn't leave room for the f of part. So this is f of all this stuff, which is f of 24 minus 5, which is 19. And then f of 19 is 2 times the stuff plus 3. So that's 38 plus 3, which is 41. Or if you wanted to write it a different way, the way that I did the first two questions, you would say g of 6 is 4 times 6 minus 5, which equals 19. And then you would say f of 19 is equal to 2 times 19 plus 3, which is 41. Okay, number 3. Let's ask ourselves, what is g of h of 2. So we got to take whatever is going on inside G, we got to figure out. So H of 2 is stuff squared minus stuff. And what is our stuff in parentheses? It's 2. 2 squared is 4, minus 2 is 2. This is going to be G of 2. And G of 2 is 4 times 2 minus 5, which equals 3. Now, I've been very adamant about writing the numbers in parentheses. Why is that? Well, let's do a different question. Let's say we do h of f of -10. That might give us a slightly large number to work with, but that's okay. We've got calculators. All right, so f of -10, what does that look like? H of 2 times stuff plus 3. 2 times -10, which is 2 times -10 is -20, plus 3 is -17. And now h of -17 is stuff squared minus stuff, and the stuff in question is -17. 17 squared is 289. The fact that this is negative doesn't matter. Negative times negative is a positive. And minus -17 is like a plus. So this is going to equal 306. Now, what if I didn't write parentheses? Let's explore what this would have looked like. Without parentheses, this would have been h of 2 times -10 plus 3. Now I put a dot here, but it's really faint. You can barely see it. If you got confused, you might have done 2 minus 10. Obviously, that's bad. But even if you don't make that mistake and you do h of 17, now let's write h of 17, -17, without the parentheses. -17 squared minus -17. All right, this minus negative you'll probably do correctly. You'll go, oh, that's like a plus 17. But -17 squared is not the same thing as parentheses -17 squared. It's one of these obnoxious rules of algebra, of arithmetic rather, that says that you're going to do the exponent before the multiplication, and the negative in front is like saying times -1. This is actually -289. If you didn't write parentheses, you would have gotten this question wrong. So do watch out for that. That's why we write parentheses, is to avoid making silly mistakes like this. And in fact, we can make even more severe mistakes when we start plugging in expressions rather than fixed numbers. So let's suppose that we did this with x. So I almost used the same color as our expressions here. So 5. Let's say we did f of g of x. So we're doing f of g of x, 4x minus 5. And f is 2 times stuff plus 3, and the stuff is 4x minus 5. So we have 8x minus 10 plus 3, which is 8x minus 7. If you had been so tempted as to, instead of writing parentheses, to write a times sign, you probably would not have distributed the 2 into the -5. So obviously that is bad. So, okay, let's do another one like that where it's just a value, only in this case, instead of x, I'm going to use c. So I'm going to say h of, we did h of f, let's do h of g of c. Now, if you'll recall on the previous set of instructions, I said c is some number. It's just we don't know what that number is. So let's not get weirded out by the different letters that are floating around here. G of C is 4 times something minus 5, where the something is a C. So literally, this is just 4C minus 5. All right, what is h of 4C minus 5? Well, it's parentheses squared minus parentheses, and our parentheses contents are 4C minus 5. And now we have to do some multiplication with some FOIL. If you write this as 4C minus 5 times 4C minus 5 and multiply it out, you're going to get this. Take my word for it if you don't, or multiply it out yourself and see, which is going to result in that, which is 16C squared minus 20C minus 4C is minus 24C. That's collecting like terms, and plus 25 and plus 5 is plus 30. So we have a very uncomfortable looking expression because it's not a nice, neat, tidy number, but that's a perfectly reasonable result here. All right, 7. What happens? No, not 7 parentheses, 7 period. What happens if we were to do g of h of 2a? Is that bad? Is that hard? Well, it's g of whatever's going on inside. What's going on inside is something squared minus something. And the something is 2a. So we've got g of 2a squared. We have to square the 2 and square the a because they're both in parentheses. 4a squared minus 2a. All right, and now g of 4 times stuff minus 5, 4a squared minus 2a, which is 4 times 4a squared is 16a squared. 4 times negative 2a is negative 8a, and we still have minus 5, and there are no like terms to collect, so we leave it alone. One last one, and then I'm going to call it a day here. So what if we said number 8? What if we said g of f of 2, no, we have a 2 already in this question. What if I said 8 minus x? All right, this looks like it might be gross, but let's find out. G of f. F is 2 times stuff plus 3. And the stuff is 8 minus x. So we've got g of, distribute, 16 minus 2x plus 3. The 16 and the 3 we can put together to make our lives a little easier. So that's 19 minus 2x, or negative 2x plus 19 if you prefer. And now we got to do the g of x. So that's going to be 4 times something minus 5. And the something is 19 minus 2x. All right, 4 times 19 is 4 times 20 minus 4, so that's 76. 4 times negative 2x is negative 8x minus 5. 76 minus 5 is 71 minus 8x, or negative 8x plus 71. I'm going to leave you with one final thought here, and that is that there's nothing that says the composition has to stop at just 2. We could have done f of g of h of 1 and triple layered it. And that would mean that we would have to say, what is h of 1? And then go, okay, so it's f of g of whatever that number is. And then we would have to say, what is g of that number? And go, okay, it's f of that result. And then figured out what f of that number was. So h of 1 squared minus 1 is 0. Okay, so this would have been a 0. G of 0, 0 minus 5, this would have been a negative 5. And 2 times negative 10 plus 3, this would have been a negative 7. So that's very doable. And of course, don't confuse the notation fog. You can certainly write it this way as well. It means the same thing. This does not change the problem in any way. It's just a different way of writing it. Just like the square root of x is the same thing as x to the 1/2, and you can write them either way. Just like 0.5 is the same thing as 50% is the same thing as 1/2. They're just different ways of writing the same thing. So I have chosen not to use the fog notation, which is really a little circle, not an O, but I know everybody calls it fog. Your teacher won't call it fog, but all your students, your classmates will. So don't get weirded out by fog. Don't get fogged over by the fog. As long as you don't get lost in the fog and you can handle all of these, plug into the inner thing and then plug into the outer thing, I think you should do just fine. So good luck.